Okay, cool. So let's continue. And now what we're going to do is to kind of introduce you to different course environment components that we will use during the course. So as you already know, all the materials are on this dedicated website that we will use. And basically we will update the page every week. So every Wednesday morning you will have new materials coming up to this page. And as you can see on the left side here, you have this kind of nice navigation panel that you can click on different topics, and then you can basically go really easily through different parts of the course pages. In addition, if you want to go, by the way, back to the front page, you can click on this icon here and it takes you back there. But basically, what you can also do is that if you, especially when we start having much more content on the website, so what might come really handy is to use the search function here. And basically what you can do is to, for example, try to find word data from the website. So basically it gives you all the places where this data word was mentioned, and it can be really handy when you are searching for specific topic that you're interested in. But yeah, then about the actual course environment. So here we basically have the different tools that we are going to use. So basically we will use this kind of modern tools and applications for doing different stuff. So basically what we are going to use for doing the actual programming is to use this kind of Anaconda Python distribution package that makes your life much easier to do all the installations and basically add different tools for you to use later on during the courses. So that we will use, and with Anaconda there comes this kind of IDE that stands for Integrated Development Environment. Did you mind zoom in a bit? A little bit? Cool. Yeah. Now at least you can see it. Yeah, so we use Spider for doing the programming, and you will see it already today, what we mean by that. And then basically how you will give your tasks and return your assignments and exercises during the course is that we are going to use GitHub. How many of you have heard of GitHub before? Okay, quite many of you. So it's this kind of dedicated web page for sharing programming work and doing this kind of collaborative working, mostly related to programming, but also other kind of work that is done. Basically, for example, the course materials that we are now showing you, they are run on GitHub. So basically, you can do all sorts of stuff with GitHub, like maintain web pages. So basically, you will today, the exercise has one task that you should create a GitHub account for yourself if you don't have that yet. So we are going to use version control and GitHub, and next week we will tell you a bit more what we mean by version control. Then instead of using Moodle, that is basically used quite a lot at the university for doing courses and giving information and doing also communication. So we won't use that. Instead, we will use this application and software called Slack for doing the communication, which is really neat and handy tool for basically chatting and asking questions and giving comments and so on. So that is one component. And then, as you already saw, so basically one is that we are going to continue using these interactive real-time polls for you to actually ask you questions and get some answers. Yeah, and then basically about how to do programming. So I guess quite many of you will now install this programming environment for your own computer. But if you don't have a computer, or if you just don't want to install the softwares that we are going to use, it's also possible to use this kind of dedicated cloud computing environment that we have created for this course. We used it last year and it worked quite nicely. So basically, to be able to use the cloud computing environment, you just need to have a laptop with internet connection and a browser, and that's it. Basically, then you can get access to the remote computer that is on the servers of CSC running there with all the software and all the stuff that you need, and you can start programming there. That can be really handy, especially if you are at some place where you actually don't have your computer, but you can access, for example, the computer in the library where they don't have the softwares, but you can always start launch this kind of remote computer and start doing the work. So that's one possibility. And then we also have the Spider and the Anaconda, so the Python programming softwares installed on the GIS labs. So basically the practical sessions we have on those classrooms, so there should be the software available. Cool. But I guess.
Can I maybe add one?
Yeah.
One thing I think that is worthwhile if you want to do it is set your own computer up with the Python software, because although we have the cloud available and you can certainly use the machines in the GIS lab, it seemed like last year there's just maybe one small additional step of having to like connect to the cloud computers. I think just limits how much you're going to want to just tinker around in Python. And if you really want to try and learn how to program and start using it, it's best if it's just on your computer and available right away. So we kind of shifted the emphasis this year to suggesting people use their own machines rather than the cloud computers.
Yeah.
You're free, of course, to use the cloud machines. We provide them for exactly that purpose. But I think, we're going to spend some time this week just to make sure that everyone who wants to have the Python software installed on their own machine can do it. And I think it'll make things easier.
Yeah.
Especially going like after you finish the course, that you can then continue on easily working with what you already know.
Exactly. Yeah. Yeah. But the idea now is that I shortly kind of introduce you to these different systems. So let's continue with actually just showing, if anyone is interested. So I will just show you the cloud computing environment. So basically, if you want to use it, and I will send you invitation links to this system, but there is this, I don't know if you see it well, but it's this pb.geo.helsinki.fi. So we have this kind of dedicated website for the cloud computing resources that we have. Okay, where did it go? Basically what you need to have, so this doesn't work with your university account, but instead I will send you links to here. Let's see if I can. Oh, I'm not a Mac user, so how do I get the @ is it shift and cool? Yeah, here it goes. Like this. So I log in to here. Okay. Cool. And basically what you will see when you log in, it's a little bit different because I'm the kind of admin person here, but basically what you will end up seeing is this kind of web page. And basically when you click on the button launch new, so what it will do is that it will actually launch a computer running at CSC. It will take a while, so you can see that it's kind of getting ready, and it opens up your computer that is alive for 5 hours. So the thing with these remote computers is that because we are using resources to actually run the computers, so that they won't last there forever. Instead, after 5 hours, they will basically shut down the computers. And if you haven't done and saved your work from that remote computer, it will be destroyed forever. So that was also last year kind of a little bit of motivation to use version control and continuously use this GitHub, because you needed to save the work to GitHub so that we can actually go through them, but also that you get the practice of actually saving your work to using version control. But okay, so now this computer is running. We can see that there is some stuff happening here. And basically what you need to do to be able to access the computer, by the way, Dave, I might need your help to get access with Mac because I haven't done it. But basically what you need to do first is that you need to open kind of a door for the computer. So you can think this remote computer of being a house with many doors, but you don't have any door opened, so everyone is locked. And what we will do here is that we basically will check the IP address of this computer, and in your case it will be the address of your IP address of your computer, and we will, by clicking this change client IP, it will open up the machine for your specific computer. And that allows, so your computer stays secure, no one else can access it except you, and everything stays safe and so on. So that's the purpose of it. So then now we have basically things ready to actually get the access. So what we will need to do to access the computer is that we need to have this address here. So this is the IP address. So this is the physical location where the remote computer is. And we need to copy that. And maybe you do it as you're more professional with this. Cool. Did I get that? Yeah. So basically, and then
so this will be this will be a bit different for Windows users, but for Mac users, there is the option to go in Finder to go and then connect to server, and then you can put in this server's address right here, which seems coincidentally to already be the one I have pasted in there. These instructions about how to connect from Windows, how to connect from Mac, how to connect from an iPad, all that stuff is on the course webpage. So don't worry so much about this at the moment, because
we'll just show you basically what are available. So
yeah, so we connect and then we're asked for a password, and I think
we
go from here.
Yeah, so then we put the password, which is Geoman, and then you connect, and basically what you end up having is to have this remote computer, and it says some kind of warning message that okay, this will be terminated after 6 hours. Well, actually it's 5 hours. We need to change that message, but basically, so now you have this window and you're inside another computer. So basically what we have here is that we have a Ubuntu operating system running on the computer, and we have all the necessary softwares installed here. So this is the terminal window where you can basically do stuff with the computer, and here we have the Anaconda and we have the Spider. So basically, and we have Chrome for doing browsing through internet, and we have also Quantum GIS installed here. But basically what we are going to use during the course is actually that we basically will use the Spider. You can launch it by double clicking that, but maybe the safest thing is to just type in Spider, and it starts opening up the IDE, which is basically kind of a software or tool that makes programming easier. So what you will be using a lot and seeing a lot during this course is this kind of environment where you can actually write code in here, and these are the places if you want to save your code, you will write it there. But we will go through this more later. today already. Cool. So basically, that is how you can basically launch a computer, a remote computer, and basically after you're done with it, we hope that you will destroy it. So basically now when I press this button, it will actually shut down the computer, and if I haven't saved, okay, at least it should, because it's somehow stuck. Okay, some technical difficulties. Okay, so yeah, so now it asks, do you really want to destroy it? And yes, you want. But basically now, if you haven't saved your work from the remote computer, you would lost it. So that's
maybe worth emphasizing yet again.
Yeah.
That nothing that you save on the cloud computers will be kept under any conditions. So if you save files thinking that you can log back into the cloud computer to use it the next day, it's always a blank slate. It's exactly the same starting place every time. So this was good in terms of making sure people save their files on GitHub last year, because you simply have no choice to save it locally on the cloud computers. And I don't, want you thinking that like 3 in the morning the day before some assignments due, you're just tired. I'll just save it and finish this in the morning. Please just burn it into your brain that you cannot save files locally on the cloud computers.
Yeah. So basically, I think now quite many will use your own computers, which is nice, so that the work will stay at your own computer and stay there for good. Of course, still we need you to upload the files to GitHub. So basically, what is Git and what is GitHub? So how many of you have used or at least heard of version control? We have a few. Okay. So we will discuss more about version control next week. But basically, it's a way how you can actually get rid of having files, for example, to keep up and maintain the history of your files. So, for example, if you have master's thesis document final 1, final 2, final 3, final 4, as you are putting the versions to your supervisor, you will get rid of that with version control, because we actually work on the same while, and version control keeps track of the changes that you have done to that file, and you can go back in time, and that can help you a lot when you are doing work. So Git is basically that, and it was actually developed by rather famous Finn, Linus Torvalds. So he's the father of that program as well. And basically GitHub is this kind of online environment where you can actually use Git to communicate with the website. So basically, if we go to github.com, so here, okay, there are some information. We have done some work for the course here, so we can actually go and see basically all the materials that we are doing here in the course. So they are actually on this kind of GitHub repository, and here we have all the lesson materials available openly. But basically this is GitHub. So it's just a place where you can basically put up files, and we can interact and collaborate and do the development of course pages together. So that this is kind of the common place where we kind of share our work. So this is also what you will use during the course a lot. So all the exercises except this first one, we will basically distribute through GitHub, and you will share your results and your answers in GitHub, so that we can actually go through them later on in the course and give you grades. So that is one part. We have plenty of them, but don't worry, we will use them a lot, so you will get used to them, and it's not that fancy or anything, but then for communication, as I said, we will use Slack. And what is Slack? So it's kind of a fancier WhatsApp and a bit better way. So how this is better compared to whatever messaging system, Facebook Messenger or WhatsApp, is that basically you have this kind of feed that you can discuss about things, but in addition you can actually put them into different channels. So here we have channels for each lesson and exercise, and what we hope is that basically if you have a question about lesson 1, you would basically click on the, let's do this a bit smaller, you will click on the lesson 1 and write your message here, question, comment, whatever you want to say, and put it here, and then we can respond to you, or your friends, classmates can comment if they have some idea that okay, this might be wrong in here. So it's kind of a common ground to do communication between all of us, which is really nice. Okay, Vuoko is around. So this is it, and basically what you can do here is that, of course, these kind of really common ways of communicating that are in Twitter and in Facebook and in WhatsApp is that you can basically, for example, I can say with @Vuokko, so I will assign, or I will target this comment to Vuokko now, and I will say hello to her. Oh yeah, it's not, well, they would say hello to her. But anyway, so you can add comments and so on. And then basically one really handy thing is that if this would be a kind of a good question, like that has a lot of comments around, so you can also basically start a new thread from that. And what I mean about thread is basically when you put your mouse on top of this comment, this button here says that start a thread, and what it does is that basically it opens up this kind of window here on the right panel, and you can start discussing about the topic in here, so that everything stays under the same comment. So basically this is what we recommend you to do, that if you have a question or someone asks a question, you will basically, if you have a comment on that one, you will start a thread and then basically continue discussion there. So we can keep things nicely organized and things are easy to find on Slack. So this is kind of a common ground for you for discussion, and how you will get access to this is that we will today send you all invitations to join Slack, our Slack team. So our Slack theme is called Geo-Python 2017. And then if you don't have Slack account yet, you need to create one. It's free to do, and just then continue and come into this site and you can start discussing. Yeah, then is there something else? Okay, well, this is actually quite nice. This is from last year, but this same thing goes in the same manner this year, except that you don't necessarily launch a remote computer instance. But this is the workflow, how we will work throughout the course, is that basically you will have you will do the work on your local computer, or then you will launch this remote computer. But anyway, either one, this side you have a computer that you work with. And then basically you will get the materials from GitHub, so you will kind of clone the GitHub repository to your own computer and then work on it, and then save your work back to the same repository where you have cloned the materials. And by cloning I mean basically downloading materials from there. In Git language it's called cloning. Yeah. But that's for basically all the different components of the course environment that we have for now. So I guess, do you have any specific in mind, something that is confusing or anything, or do we just continue? Silence.
And some of these things are going to become familiar just by virtue of using them as we do some of the exercises. So it's probably the case that you're a little bit confused about why we use GitHub and Slack and this website and this other thing and blah, blah, blah. We hope it'll become clear as you get just a bit more familiar. We do have reasons behind doing these things this way.
Yeah, these are basically all the things that we will teach to you to use are something that are regularly used in industry if you go work outside university. But for example, all these things we are also using in our research group. So we are actually using Slack for communication, as we have 5 different projects running on. We have 15 people working. So having like one WhatsApp chat for all that would be impossible, and we don't want to use like emails for doing everything. So Slack is really good for communication in that sense. Okay, but if we're good to go, maybe we can actually take our first taste of Python, and Dave will continue from here.
Yeah, so for those of you who do already have maybe Anaconda installed on your computer, you can follow along and actually do some of the things that we're going to go through. Otherwise, the lesson for what we're going to do in Python today is fairly simple. And I would even say it's something you could follow even without a computer in front of you. But just to kind of give us a sense of what we can do in Python, and we'll continue on with this, of course, in the following weeks. So for those of you who do have a computer in front of you and who maybe already have this Anaconda software installed, you can start, if you want to follow along, by launching the Spider program. In Windows, that can be done by going to, I don't know, the little circle thing. Is that the start button? What's that in the bottom left?
Yeah, the Windows button.
Windows button. And then is it to programs? I just kind of guessed about this.
So the Windows button, all programs, and there should be a folder called Anaconda 3, and under there you should find Spider.
Yeah. And so that's how you should open Spider in Windows. If you're on a Mac or in Linux, you can do this in a terminal window just by typing the word Spider. If you don't know how to launch a terminal window at this point, that's okay.
You can show.
I can show that. So if you're using a Mac and you don't know about it, you can do Command Space to get this little spotlight search thing to pop up. And in there you can type in terminal, and more than likely that will be the only thing that comes up. And once you do the search for terminal in Spotlight, you can also click on the Spotlight little magnifying glass on the top right. Once you do that, you can hit enter and it will open a terminal window, and you probably won't get these warning messages that I get, but let's see if I can make this default.
Make it larger a little bit.
Maybe like
yeah,
that.
No, at least I can see.
Okay. And in here you just can simply type in Spider and hit enter. And you know, if you're having trouble with this, we do have 5 of us who are not sitting at the front of the room right now, and we can help out. If you just raise your hand, we can maybe come around and
maybe good to specify that if anything is unclear, Thursday and Friday sessions are then to get you really started with the terminal Windows, Spider, and computer. So if this is a bit confusing for some, just watch and follow, and we can check that everybody has their own working environments running by the end of the week. So just relax and follow it.
Yeah, that's a good point, Volko, because one of the ideas on Thursday is that we will help you do the installation of the software if you're having problems. So don't worry about it if you don't have Anaconda right now. This is really just for those who already have it in front of them and feel like following along. So I'm going to type in Spider here, and I'll get some warning messages that I'll just ignore. And this is the Spider window. It looks like there's an update. It looks just like the one that Hendrik pulled up in the cloud computer, and I'm going to also, although this is what it looks like by default, I'm going to slide things around a little bit just because we're going to work down here in the bottom right panel of the Spider window in the IPython console, and I'm going to just see if I can make the font size a little bit bigger. So that may take me just a second here. IPython console. Maybe I can't easily make that bigger. Shows how familiar I am with this. Okay, hold on. There we go. So we'll go with maybe size 18. Is that okay for the back of the room? Can you read what's down here in this panel all right? Yeah? Okay, so here we are in Spider, and I'm realizing now that this is going to be a little bit tricky to switch between here, but we're working down in the bottom right panel, and we can start out here by just looking at some things we can do in Python. So the whole lesson is also available on the website if you want to just look at that as we go through things. So as we note in the lesson, you can use Python to do very simple things like math. So you can type in 1 + 1 and hit enter. And in the IPython console that's shown down here, you'll see things that are listed as inputs are shown with the word in, and outputs are shown with the word out. So input number 1 gives you output number 1. In this case, it's the number 2, which is what happens when you do 1 + 1 and hit enter. You could also do 5 times 7 and hit enter. In this case, multiplying, you're using the star, asterisk, and of course you get 35, just like we would expect. No big surprises here in terms of how this works. Would it be possible for you to pull up the lesson on your laptop just so I can not switch between the... So of course, you know, we can do this basic kind of arithmetic, multiplication, division, adding, whatever. We could also do a little bit more fancy things like trigonometry. And if you're tempted to do things like calculate the sine of 5, you could type in sine and 5 and hit enter, and more than likely you're going to get something that looks like this. There's also a function called square root. And you might think, okay, well, I'll just type in sqrt, that is the name of the square root function, and hit enter. And in both of these cases, you get an error message. Now, it's not that Python can't calculate the sine of 5 degrees. It's not that you can't calculate the square root. But in this case, we have to tell Python that we need a little bit more in terms of the available functions, the available things that we can use to do calculations in order to do things like calculate the square root or the sine of some angle. So there's built-in stuff that happens, you know, as soon as you launch Python, you can do 1 + 1, 4 - 1, whatever. These kind of basic arithmetic. You can also do, if you want to say 2 to the power 3, so 2 cubed. You do star star, so that's how you raise something to a power. And of course you get 8 when you do 2 times 2 times 2. That stuff's built in. If you want to do something like calculating the sine of an angle, you have to bring in additional functionality to Python. We do this by loading something called a module. And a module you can think of as basically like a toolbox. It has a whole bunch of different things you can use to do calculations. So for instance here, and I guess that's all right, we can bring in a module called math using a command called import. Import basically just says load in things that are part of this module called math. And if you do that and hit enter, nothing happens.
But now we have this module called math where we can do something like math dot sine of 5. And when you do now this calculation, you do get an answer out of here. So what happened? Well, we've loaded in this set of functions, things like the sine, the square root, that can be used as part of math. And then we say, when we want to use that, the name of the module that we've loaded, in this case math, and then the function that we want to use, and they're separated by a dot. So now we can do math.sine of 5. We can also do math.sqrt for square root of 4. And as expected, we get 2.0. Now, this you'll see with the math library. We'll use some other modules later on in the course.
Yeah,
and
there are basically thousands of these kind of toolboxes that you can use for different purposes. So, for example, in the GIS course, we will use specific modules that are designed for doing GIS. And I guess you are doing something similar.
Yeah.
Yeah.
And it's you can think about it this way, that when you open Python at the start, it's very stripped down. Nothing is loaded by default because it wants to be efficient. And so only when you load in certain modules do you get these additional functions. There's also things like within a module like math, if you type in math.pi and hit enter, it will give you the value of pi. So you can have functions like the sine function, cosine, square root, lots of other things that are in the math library. And you can also have values that are defined as kind of a constant. So math.pi, for instance, which means you could then do like math.sine of math.pi. Does anybody know what the sine of pi is? Just a little math quiz. It's going to be between -1 and +1. Okay, yeah. So we got one bold person, 0. Okay, you're right. Exactly, the value is 0. In the computer, you get a value that's very close to 0. In this case, 1.2 times 10 to the -16. We don't need to talk about why this is right now, but computers have a bit of a hard time representing values exactly that are close to 0. Anyway, it's basically 0. I think we can agree that 1 times 10 to the -16 is pretty close. And so, we can do this thing where we use some function. Function just going to calculate some value for us, like math.sine. We can also combine functions. So we had this thing we saw in the lecture earlier called print. And so you could do print math dot square root of 4. So here we have one function called print. And inside of that, we're using another function called the square root. So I've just kind of put some space there just to help you see. And of course, as expected, we see the value that comes from when this function is executed. When you calculate the square root of 4, it says it's 2, and then print just says display that on the screen. You might say, well, why would I want to do something like that? Well, it's because you can do things like print the value, or maybe I'll do it this way, the square root of 4 is math.sqrt of 4. So now I have in the print statement some text that's enclosed in quotation marks, and then a comma, and then the value of or some function that's going to be calculated. And if I do this, then I see the square root of 4 is 2.0, just like we expected. So this is a nice way to be able to combine things. You can have functions, and if you really want to get carried away, you can have functions inside functions inside functions. There's reasons why it's not good to do that, but there are lots of ways in which these things can be combined with one another.
Yeah, one really kind of important thing related to any programming language is kind of how you, if you want to specify a piece of text that you want to set on the screen. So basically it's the similar way in each language. So if you want to print out the square root of 4 is something, you need to put it in the bracket like this. So this would basically work like Dave will show you. So he will say hi for me. But basically, if Dave would do this without those, what are those in English?
The parentheses?
Yeah.
Or the quotation marks?
Quotation marks.
Yeah, so here we can show an example of something without quotation marks. So I do print hi Henrikki and hit enter, and I get an invalid syntax message. Now, this unfortunately is something that's going to be a bit confusing in terms of the error message at this point. But maybe we'll come back to this example. But the same thing goes that if I put just the quotation marks and not the parentheses, I get some error message. In this case, that's actually quite helpful. It says missing parentheses in call to print. That actually tells me something pretty useful. Not all error messages are going to be that useful. But the reason why this error message is so specific is because the old behavior in Python 2 was that you didn't have parentheses for the print statement. So they knew lots of people were going to have this problem. The important thing, again, is when we talk about syntax with the computer, we talked about how things are exact and precise. You have to give all of the pieces that are expected in order for this print statement to work properly. So we've shown a little bit of printing stuff, and we can take a look now at some other things, like variables and assigning values to variables. So we could take something like temp _ Celsius and say that's equal to 10.0. So what have we done? Well, we've taken some number here and we've stored it in this variable called temp Celsius. And if we now print out what the value of temp Celsius is, we get back the value that was stored in this variable name. One thing that we can perhaps note at this point is if I printed out in quotation marks temp Celsius, what's going to happen? It's going to put the words temp Celsius instead of the number that we stored in that variable. So when you put something in quotation marks like that, you're saying this is a set of characters I want to have displayed on the screen. If you don't put the quotation marks around some variable name, it will then display the value that is stored in that variable. And you'll get some practice actually with this in the exercise for this week, just to kind of help learn a bit of how that works. And we can do other things like we talked about the example of this calculator to calculate temperatures in Fahrenheit. So we could say temperature in Fahrenheit. And I guess we'll do it like this. So you'll notice it doesn't make a difference whether you use the double quotation marks or single quotation marks, at least in practice in Python. Those are, I think, effectively the same. But what we could do now is we'll put some text and we could say, well, how do we convert Celsius to Fahrenheit? It's 9 divided by 5 times temperature Celsius plus 32. It's a very obvious conversion. So, and I'll just again put some spaces here just to make things easy to read. And now, if I've typed this in and hit enter, I can see that 10 degrees Celsius, if I've done my math correctly, is 50 degrees Fahrenheit. And so we've combined not only here a little bit of text in our print statement, but actually a variable and some calculations that are done to that variable. So it's a nice example to see that you can do more than just print the variable name. If it's a number, you can multiply, divide, do whatever you want to the number within this print statement. So that's nice. And one other thing I'll just highlight here, as noted in the lesson, is with this variable temp Celsius, this is one kind of style of variable naming that is very common. I think they call it pothole case, because this sort of underscore looks like a little hole. But you have, something like temp or temperature underscore, and you want to specify that this is the temperature in Celsius. So you can do that by temp underscore Celsius. You can't have a space in the name of a variable. So this is the way of connecting two words that go together. And a very common, and I would say kind of good format for naming variables.
The other way of what you see quite often is this kind of camel case naming.
Yeah, we'll see that one in just a moment. But if you compare that to saying like TC equals 10, I know what TC is. I know it's temperature Celsius. If you're not sitting in this lesson and you see TC, you're going to be like, what does that mean? And so there are things like this, small things, how you name your variables, that make a big difference. It might be convenient to type in some short name for a variable, and it's not that you should make your variable names 300 characters long, because that gets just difficult to read. But you can, put a little bit more information in here, like temp underscore Celsius, that tells me this is the variable storing temperature, and it's storing temperature in Celsius. We can change our variable name, or our variable value. So we could take Celsius and reassign a variable value of 15. And now if we say, print temp Celsius is now I'm typing a bit quickly, so if you're trying to keep up, I'm sorry about that, but you can see that we've changed the value that was stored in temp Celsius. It was 10, now it's 15. And so variables, their values can be reassigned and changed. So when you set something, if it gets reassigned somewhere else in your program, for instance, it will not remember what was there before. There are some exceptions to that, but we won't encounter
so basically
many of them.
In programming, you don't kind of update any value of any variable. Instead, you kind of destroy what it was before, and then you kind of have a new value.
Yeah. So and we could also, let's say, temperature in Fahrenheit. And rather than maybe having to put this little formula into our print statement, we'll just separately calculate what the temperature is in Fahrenheit. And again, of course, as you all know, 9/5 times temp Celsius plus 32. And I hope that my sort of tone of voice carries that I'm not being serious when I say that you all know this. This is a sort of ridiculous thing to calculate temperatures in Fahrenheit. But we can calculate temperature in Fahrenheit, and then we could have a print statement where we could say temp Celsius is temp underscore Celsius, and temp Fahrenheit is temperature in Fahrenheit. I hope I've spelled all that correctly. And when I hit enter, I see temp Celsius is 15 and temp Fahrenheit is 59. So remember, now we've calculated our temperature in Fahrenheit from a different value of temp Celsius. And another thing just to point out here, again, I'm sure if you're typing this, you're maybe having a bit of trouble keeping up, especially spelling Fahrenheit correctly. But this is another format of variable naming here called camel case, where instead of having underscores to separate words, you use a capital letter at the start of any new word. So when I assigned temperature in Fahrenheit, you can write temperature if you want with a lowercase or uppercase t. People do that both ways. But then when I have the word in, I use a capital I, and then Fahrenheit, I use a capital F. Again, it's easy to read. It's a little bit more compact in some cases because you don't have the underscores separating things. Although I've spelled out temperature this time fully rather than temp. So what we'd like to see from you folks is that you adopt one of these two variable naming formats and avoid things like TF and TC and F and X and like just using these like single letter variable names. Unless it's extremely obvious what you're calculating, it just makes your code harder to read. And it's just unnecessary. It doesn't, you don't gain much from having a variable name that's 2 characters instead of 5 characters or whatever.
Yeah. One kind of important thing to notice from here is that what we are actually doing there when we are printing this information, temp Celsius is 15 and temp Fahrenheit is 59. So as you can see, we are kind of chaining these things together. So we are actually taking a piece of text, then with comma, we can actually say that, okay, now comes another thing. And in our case, it's now the value from the variable temp Celsius, then another comma, and we can chain another piece of information into that same print statement where we have the text, and then again, another variable. So it's really easy in this way, kind of have pieces of information from different pages, putting them together, and then print out the outcome that is text in a human readable way.
Yeah, so, and one other thing just to note here is that programming in Python is not quite like using Microsoft Excel, for instance. So if we change the value of temp Celsius to be now equal to 20 degrees, we did have this formula earlier that we typed in where temperature Fahrenheit equals 9/5 times temp Celsius plus 32. If I just push up here twice, this will let me go back to things I've typed in previously in the IPython console. So what I'm going to do is just print temp Celsius is temp Celsius and temp Fahrenheit is temperature in Fahrenheit. This is something we just did, but now we've changed the value in temp Celsius. If I hit enter, what I see is that temp Celsius is 20 and temp Fahrenheit is 59. When we assign the value to temperature or to temperature in Fahrenheit, we did it with the current value that was stored in temp Celsius. If you change the value of temp Celsius, it does not change the value in temp Fahrenheit. So if you're used to Excel where like maybe you reference a cell and you change the value in that cell to calculate the value in a different cell, that's how Excel works. That's not how the programming works in Python. In Python, you store the value when you calculate it. And for the most part, that's how things are going to work. There are cases where you can get a little bit different behavior, but we shouldn't encounter, I don't think, any of those.
Of course, way how to handle these things, but that we will go through.
There's pointers and things like that where you can reference values, but we're going to keep it simple here. So so just a couple other things here in Spider. We've been working down here in this IPython console. I'm just going to see if I can get the slider here and slide this down a little bit. And we've assigned some variables. One of the things that's nice in Spider is there is this thing up here, this upper panel where you have right now loaded the help. But if you click the tab for the Variable Explorer, what it shows is the values of any variables that have been assigned in the session that you're using in IPython. So we see currently that temp Celsius is the name of the variable. Its type, which we'll get to in just a moment, is as a floating point value, and the value that's stored there is 20. Temperature in Fahrenheit has a value of 59, and as you have many variables in here, as you start to write your little programs, you're going to find cases where maybe you can't figure out why something's going wrong. This is a useful place to look and say, like, well, what are the values that are stored in my variables? You can print them out to the screen as well, but this is kind of an easy way to get that information without having to print something to the screen. So there is also a command in IPython that you can use called %whos. And I think, is there a second parenthesis? No, it's just one. And if you do %whos, it gives you a lot of the same information. It also shows you here that the math module has been loaded, but it shows you the variable names and their values. It's kind of up to you. I think if you're in Spider already, you might as well use the Variable Explorer. It's just easier. And other than that, we're going to do one last thing here and just talk a little bit about data types, and then we'll show you the exercise for this week, and we'll be done for today. So what we saw when we got this information in the Variable Explorer is that we have currently 3 variables, and they're all of type float. And that's used to store decimal values. So it's not a surprise we have things like 20.0, 59.0. Those are decimal values. We could also make a variable called temp whole number and say it's equal to 20 without the 0.0. And now, if you've got this Variable Explorer open, we see temp whole number has a different type of data. It's an integer, meaning it's a whole number. It's not a decimal value. And so there's 4 basic data types in Python. There's floating point values, there's integers. We could say, let's see, nice underscore guy equals Henrique. We can certainly store a character string as a variable. So now we have a variable called nice guy. It's a type str, means it's a string of characters, a list of characters combined, and it has a value of Henrique. We could also say, maybe make another one, variable called am I hungry? And we'll say that variable has a value of true. And if I hit enter here, now I see yet another type of variable. In this case, a variable name is am I hungry? Its value is true, and it's a type of variable called a Boolean, which is maybe not that familiar of a word, but it basically means it's either a true or false value that's stored in that variable. So, these are just different data types that you can use. Not really, I kind of diverged a little bit from what the lesson shows online, but essentially you see the same thing there. The only thing that's really worth noting about the variable types is that sometimes you can get kind of unexpected consequences when you combine data of different types. So for instance, if I try to take nice guy and divide it by am I hungry, I'm not really sure what this would mean in terms of what I'm trying to do with this program, but if I try to do that, what I get is an unsupported operand type error. What this is saying is you can't divide a string of characters by something that's true or false. Logically, that makes sense. I mean, I don't even know what I'm trying to tell the computer to do if I say take Henrique's name and divide that by true or false. Now, if I took something like, temp Celsius and divide that by, I don't know, temp whole number, that's not a problem. Python's like, okay, you gave me a number, told me to divide it by a different number. I could do that. And in this case, it doesn't necessarily even matter that one is an integer and one is a floating point value, because those two things are both numbers and they're compatible with one another. And in Python 3, there's basically no big issues with integers and floating point numbers. Yeah. Python 2 was a different story. But here, we see things that, based on the type of data, are compatible with one another or not. There are things like, some of these might be surprising. If I said nice guy times 5, does anyone have any idea what might happen here? It does. And it just puts them one right after another. There's no spaces or anything in between. So there are instances, like if you want to have your program write something out to the screen where it's like 80 asterisks in a row to like divide some part of what the program is outputting to the screen. You could take like star times 80, and you get 80 stars in a row. If you have ways in which you want to repeat text, you can do some of these tricks. You could also, let's say, not so nice guy equals, do I want to say something political? Probably not. Let's see, who's a not so nice guy that's not politically charged? How about you? So you know, I could take something now like we have nice guy, and I could add to that. Maybe I'll put a space in here, and then not so nice guy. Not so nice guy is not defined.
No, so.
Oops. So there's our typo. I'm going to go back and fix that so that we have, instead of no so nice guy, not so nice guy. You guys are going to do this kind of thing too. And so then you can take those two strings and combine them. No problem. But if you said, well, oh, I can combine strings, then maybe I'll do some math like this and subtract things. And then it says you can't subtract strings from one another. You can add them together because that's kind of an obvious operation. Character string plus another character string, we just put them together into one. Subtracting them from one another doesn't work the same way. So that is why data types matter. And since we're running out of time and I don't want you guys to hate us from the first day, we're going to stop playing around in Python at this point and just take a quick look at our exercise for this week. This will take just a second. So the last thing listed in the lesson for today on the website is the exercise number 1. It's pretty simple. Your first task is to go on to github.com and make yourself an account. And that's even spelled out a bit more clearly here about how to do that. And then what we want you to do is to take your new GitHub account name and post a message in the One Exercise Slack channel with your name, your GitHub username, and which course you're in. And you can either call it Intro QG or AutoGIS just to keep it short. That way we'll have all the names of the people and their GitHub names together. That was a bit of a challenge last year because we had them send just their GitHub names. And we'll also have which course they're in, which also helps us just sort out whose GitHub names go with
and
who.
we will send you invitation for the Slack team that we have. So at the moment you cannot access it yet, but we will do it right after the course. So.
And so we'll have you do that. You'll post in Slack, and then you'll get to cook up some Python of your own in part 2. So you can open up Spider, and basically what we're going to ask you to do is to create a string variable called name, which should have your first and last name in it. Create an integer variable called ice cream rating, and use that to store a number between 0 and 10. And the goal is to use one statement to print out something that looks like this. My name is whatever your name is, and I give eating ice cream a score of whatever the value you gave for ice cream rating out of 10. So you can express either your love or hate for eating ice cream in this week's exercise. And what we want you to do is, once you have gotten your code or your set of commands to do this, we just want you to copy and paste what you typed in to the IPython console and send either myself or Henrique an email with the list of commands. In future weeks, we're going to store everything in GitHub, but it's just a little bit too much to do all that in the first week. So we'll just go back to sending emails, which is not ideal, but that's how we're going to roll for the first week. Is that clear enough? All right. It's spelled out in more detail here that you should do this by 5 o'clock next Tuesday. The reason for that is that we need to have your GitHub usernames before class on Wednesday. So that's the important thing there. Otherwise, we're all set, and if you have questions or anything...
Yeah, and I said tomorrow and Friday way, so there are people helping you out with installing software to your computer. So if you have problems, just come there.
Yeah. All right.